So hello everybody, back online. So today we are going to continue to work on our wonderful little editor, and we will decide on what we do next. And let's probably just get a little bit inspired by firing it up and seeing what we can do next in the best way. And we will also check a little bit on the latest errors and bugs if we're really sure that they have all been addressed. So the first one, or should I say the last one, was our problems with aspect ratio. And we had different kind of issues here, and let's just really quickly skim over it. Not another stream about about ratios, but just quickly be sure that everything's still working. Okay, that looks good. So when we now stretch this or squash it, it still keeps the correct ratio. That's what we want. Of course, it will get bigger or smaller or whatever, but we still get the correct ratio. And this is what we're interested in. Yeah, okay. And now I already see something that we can and that we should address. So there is an issue now that we cannot move the camera. So I'm pressing the WASD keys, but nothing is happening, which was not the case before our last change. But now we have this issue that we have the camera not really working anymore, because we have a separate camera and this is not updating in the way it should. Okay, and the same for the level editor. And I would suggest that this is something we should fix soon. And the other issue was with not being able to select a resized editor, but this is fine. This is fine. Everything is working here. Also the game object tree is working. Okay, that's fine. That's good. Okay. So now let's try to fix this issue with the camera, and yeah, let's jump into it. So what do we have here? So the problem is that we have a function that is called check camera or something. How is it called? Or check input. Now let's go into doFrame, and it's called check. It's not check, but it's update camera. Maybe I should also call it check camera or something. Yeah, I think we will just do that. We will just say check camera inputs. So now we are a little bit more in line with the other namings here, and I think it's normally a good thing. So okay. So just a sip of water before it gets hot. So the problem is here. So what we're doing, and this is still fine, is we are just checking for specific keys. If they are pressed, that's fine. That's not an issue. But what is an issue is let's rename that quickly. I don't like that name. It's not a candidate, it's an actual location. Just makes it easier. So the problem is happening here. Because we don't really use the perspective camera in the correct way now. So there are one or two options now that we have. One would be that we still use this one camera here, and we just updated it every time when we also need to prepare our camera for a specific frame buffer, and we just use it temporarily, so to say. We just have this one camera placeholder and that's it. And that might actually be the best thing. The other idea would be that we have this, that we have at least a second camera for our 3D viewport, which we may have, but I am actually in doubt if this is really paying off, so to say. Really not sure if this really makes sense. I think we will actually try to just stick with one perspective camera. I think that makes sense actually, and yeah, we'll just see how far we come with that. So let's see. Because this means we can keep our check camera inputs function just as it is, and we will just change our specific 3D rendering pieces. What's that? Small typo. So the top menu doesn't count. It's just orthographic. The game object tree is not important, but in fact it's really just the main viewport body. That's it. And yeah, I mean, we can just do that. We can do that. Maybe we will create a second function here, which is essentially now I have an idea. We will rename this one here, and we will essentially, what we do is we create a perspective camera, because we really create a new one. And here we do something else. We activate the main perspective camera for the 3D panel. So hello. Let me see. So yeah, of course, if there are any questions about what we're doing here or about programming in C++ or whatever, yeah, just feel free to ask. Otherwise, just enjoy my rambling. So what that means is we need not a new camera here, but we need the editor state perspective camera, and we can even be a little bit more efficient here by doing this. Editor state perspective camera, and let's change that. And this is editor state perspective camera. Yep, so we can do that. And we don't even need to return it because this is kind of a reference anyway. So let's try that. Let's try that. So if we now say render level editor, this is the camera, and who calls that? It's called from here, and we just say activate main perspective camera, and it's fine actually. Yeah, let's try that out. Okay, we have a small build error. Move that up here. So what do we have here? Yeah, that's true. But this is then void. So this should work now. Ah, yes. This is true, but that means we can then just do editor state perspective camera. That should do it. That should absolutely do it. Just checking if the size is good for you guys. So font. Font. Yeah, I guess it's fine. Maybe we can make it bigger for you. Might be easier to read. Bit easier to write, a bit less so easy to write, but I guess it's still okay. This is not so important. And let's probably move this a bit to the side. No, it's the wrong. Is that it? No. Yeah. I guess that's maybe a little bit better. Oh, hope so. Okay. So, does it work? It compiles, but does it run? Does it run in the way that we want it to run? No, not really. Not really. I think we actually can skip this whole logic here. I think we might really skip this. Yeah, let's do that. I think we can make that a little bit nicer. Well, let's refactor that. I think we will just get rid of that. Yeah, I know. It's now wrong, but that doesn't matter. That doesn't matter too much. I think we will just completely skip this concept now. I think we will just skip it for now. I think we will do this differently. We will just always use this one here. We will always use the main perspective camera, and that's it. And that is it. And we do not pass this in, and I think that makes it better encapsulated, and it also is just more useful. It's just better, I think. Get rid of that. Yeah, that's fine. And this is still a problem, I guess. And we just don't do that here as well. And that's fine. We get rid of that. So, try it again. So somewhere we have a small issue still. Fine, I think we don't even need that now. Yeah, we just, we just do that. That's all good. Okay, build this through. That's good. Now let's see. And are we happy? No, we're not happy. Still not happy. What does that mean? It means that we activate the main perspective camera for the 3D panel, so that's fine. But we still need to upload it, right? Which we actually do. So why wouldn't that work? Why wouldn't that work? If we say we render the grid, we also use the perspective camera. But is the perspective camera a pointer? It is, so I mean that's fine. It is a pointer. Why wouldn't that work now? I mean, let's see once more. Render main viewport body. So we are rendering the level editor, and the level editor is correct. I mean, there's no specific separate camera here. I would think it should actually work. And it does render the game object in level edits. So I mean, the camera is still bound. It should really work. It should really work. It's interesting. Let's check once more. So if we say check camera inputs, yeah, it's the camera. I mean, the game state is a wrong variable name, but this has nothing to do with the error. This was changed to editor state long ago. Good to see it now. Update and get view matrix. Update and get. This is just regarding the view matrix, so that's also correct. It's also correct. Questions over questions here. I think what we can do is we can just see if we go here actually. I think we will actually every frame anyway, even if nothing happens. Yeah, so I mean that's maybe not so good anyway. Let's maybe say if dir equals 0 or if dir equals 0 and hdir equals 0 and yaw equals 0, just return. It's probably more efficient anyway. We don't need to do this because that means we have not moved at all, we have not rotated at all, we don't need to do anything here. Yeah, so I just press W and now we are here, and that's fine. So now we're here, and the location changed a little bit because it was originally B is -6. Oh, I see. It's horrible for you to follow. Change that quickly. Let's put that here and let's put that a little bit up. So you're not missing so much. Yeah, probably just then put it over myself or something. Yeah. So let's just do it like this. Best compromise. Screen estate is always on a premium here. So let's see. Good. So far so good. Let's just continue here, but nothing happens. Why is nothing happening? If we say, let's say, what does the activation actually do? Activate main perspective camera for 3D Painter. I mean, it should actually. Ow! Aha! Yes, I know. We cannot do that because that resets it to the same location as before, right? I think that was the problem. Yeah. If it was that, it would not work anyway. So let's see now. Hey, here we go again. This works. I think it will still not work in our mesh editor. Oh, yeah, it does. Of course, yeah. No, it does. Even better. let's import our night. We haven't seen the night in a long time, haven't we? So cool. Yeah, a wonderful Mixamo night. So what we could probably also do is maybe really make the camera, while we're at the camera, we could maybe really make it kind of all 3 degrees of freedom, or is it 6 degrees of freedom? I always forget, but to really make it also. So now we can move forward, backwards, strafe, and we can yaw, we can so rotate around our up axis, but we cannot pitch. It's maybe also allow us to pitch. I think that makes it nice. And let's try to see how I did this in an old engine. That is then a little bit faster. This is my old stuff. I can also show you that. This is my old engine here. And here it's looking a little bit different. I have made all kinds of checks to not be able to pitch too high or too, I mean mainly to not pitch completely like 90 degrees, because then the math gets all over the place. So we are currently so how did I do that? I made essentially more or less the same. I just also had the controller. That's fine. I don't need that now. We also need the up vector, of course. That makes sense. Let's just add that to our wonderful check camera inputs. We have the up. We have the up vector already. No, that's fine. So then we have the forward after the yaw. That's also. Then we have our actual angle. That is our pitch angle. It's more or less selectively reusing it. Then we have a forward after the pitch. So what I'm doing here is essentially like doing it kind of step by step. Okay, the right, I didn't have the right vector, which I want to have actually. Yes, this is now the editor state in my case here. So we're essentially like splitting our whole view camera view calculation, different separate parts. So the first one is we just take care of the yawing of rotating around our up axis, and after we have clarified that, we have a new forward axis, because if it was like this before and then we rotate, it's certainly different, right? So this is now our new forward axis. This allows us now to say, okay, we want to pitch actually around the right axis. So we want to pitch like this. Oh, it's horrible to see in the camera. But if this is the axis, we want to pitch like this. Okay. And so we use actually the forward after the yaw, which is the kind of the updated forward axis in word space essentially, but it's our local forward axis. And we have now a forward after pitch. And I think now that we can then do the actual strafing movement. Because now, I mean, we have the right axis would not change anyway. It would just change after the yaw. I'm just wondering why I do not actually update. Why didn't I update the right vector here? I'm just wondering. I mean, it's certainly possible to do that, right? I'm just a little bit wondering why we're doing that, because essentially, okay, yeah, I mean, we're really having, does that make sense? Yeah, okay. Yeah, okay, so we have the forward. I mean, the forward, yeah, I mean, it's true. The forward is actually, the forward after yaw is, I mean, it's still around the right axis. I'm just wondering. It doesn't, now when I look at it, it doesn't completely look correct, but I remember it working correctly. And then we will roll with it now, and we can see if it is working or not. And we can then just do the location candidate forward. Where does this come from? Yeah, it's this. Okay, it's the forward after yaw. Okay. Yeah, I see. So what I did here is, because you could argue, it's like in a flight simulator, if you're able to pitch, so if you're level, so let's say you're moving or you're flying in a straight line, but then when you pitch, of course, your forward vector changes. And so if you would then go forward, you could interpret it in two ways. Either you say, well, I'm looking up, like in a first person shooter, but I'm still moving in the same line, and I'm not moving actually along my forward vector. So that what I call here fixed plane forward movement. I think that's how I call it. I mean, I see that I called it that way, but this is meant with that. And the opposite of that is that it's not in a fixed plane, but you're actually following along, so you can really kind of move also up and down. And I think this is what we're doing now, or maybe not. Let's maybe start with what we call the fixed plane movement, and I will just add these ifs later. I think we will now just stick with the fixed plane, but it will still allow us to kind of move ahead. So now it would really be like more like a first person shooter and not like a flight simulator at the moment. So this is fine. We don't actually need that. And now we can just, so the location for that is just, this is the location candidate forward, and this would be just that, the forward after the yaw. That's fine. That is fine. That is fine. And so this is essentially the location after the strafing, right? So if we now have the forward after the pitch, we will essentially have it like that. So let's switch back to our new engine. So now we have, so the first location is just after the yaw, then the second location I mean, it's the same location, but it's just changing now, is essentially the forward after the pitch times the direction. Yeah, because the direction is actually, I will not call it dir, I will call it vertical direction. I think that's much better. Vertical direction or vertical dir, because this is really much better readable, not only for you and for me. It's just, I mean, it's just, I think it's objectively better to read. Yeah, could also call it up, down, left, right, or something like that. But anyway, yeah, I mean, here are some magic numbers. That's of course bad. I'll just keep it now for a moment. Let's see if this still works in any capacity or if I manage to break it right away. Anyway, I mean, the basics still work. I mean, we can still yaw. Now let's see, can we also what would actually be the key? That's a good question. What was it in my old codes? Up, down. What is up? Pan, forward, HDR, VDR, pitch. Pitch is okay. It's I put it on the on the keyboard up and keyboard down. Yeah, I mean, why not? I think later we will just or soon we will add mouse movement for that. I think that would make sense. Yeah, but we can now roll with the separate with the numpad up and down. That's fine. Just do that. If is key down, VK up, then we will say pitch equals -1 because it's kind of the other way around. I mean, at least that was it in the other engine, but that was OpenGL, so maybe it's upside down again, but that would not be the problem. So pitch, the variable we have anyway. We can just also add now if pitch equals 0, we just return, and otherwise we try again. No, I don't know what I did. I don't know what I did. Okay, just building the app is fine. That's what I did. I think I never clicked that button. I always use the shortcut for that one. Okay, fine. Okay, yeah, I mean, we broke it. Okay, nothing is happening anymore. That's good. It's probably comment this one suspect function. I think it's a spec because this is the one that is kind of using this forward after pitch. So I think this is the problem. And I think also I'm really wondering because I think the right vectors at some point must be recalculated. So I'm kind of yes, no, is that so I can show the old code, and you're invited to think with me, but I am a bit confused because here I'm saying the new write is I'm retrieving it from the camera. I mean, that's fine, but I'm not really manipulating the camera if I'm not mistaken. So why would that work? I mean, I'm retrieving it once here, that's fine. And get right is just, yeah, I think it doesn't even find it because that's essentially all dead code. So this is, I need to go to the, no, it's camera mover. I know this is in the camera, yeah. Yeah, I mean, let's just see, get right in camera. I guess it's here. And this is essentially just, yeah, it's, okay. Yeah, but that's why it works. Okay, I see. This is why it works, because we just do the cross on the current forward and the forward. No, but do we change the forward actually? It would also only work if we change the forward in between. But I'm totally not sure if you do that. I think we don't. So we have a forward vector, which is fine, but it's never really fed back to the camera. And so if this is never fed back, I'm wondering how that could work. This is the angle, this is the steepness, doesn't do anything. And again, here we just literally create a new forward vector, which is just pointing forward after the pitch. Totally nice, but nothing changing. I mean, I'm really curious how that would work and why that ever worked. How could that work? I mean, that's right, the strafing is, but we just don't manipulate the camera, right? I mean, that's the point. What did I do? It's a Luke, this is you are my code moment. Okay, here we do it again. But the camera itself is never really, it's never written to, it's just read from. Doesn't make sense. I mean, I remember that working. Unfortunately, this code is kind of broken. I think it doesn't even compile. Kind of dead code. Yeah, because it's in the old file. Do I have a new one? Did I ever do that? Let me quickly check. Because there's an old engine which has an even older engine in it. It's like a whatever. A box with boxes inside, which has boxes inside. Because this is the newer of the old engines. And did I have a camera function in here? I think I did not, because that would now be very practical. I think I did not. It seems I didn't even have that. So in my sample game, no, but in my actual test game, did I have it? My small Vulkan game. Blah, 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 blah. There's something with camera. I think I never moved the camera here. I mean, there is a look at, but it's not really, this is never moved. Yeah, that's wonderful Vulkan code. Okay, so we need to find another strategy here, or we just think it through anyway here. So I think, I mean, at first, let's just remove this kind of magic number, because this must then be the, is this the strafe? This must be the cam speed, right? So we have the movement speed here. Yeah, this is the rotation speed. And I think it's just the cam speed. Yeah, let's just remove that. Whatever that kind of fine-tuning was. Doesn't really make sense anyway. Just quickly check that it's still working and not completely out of whack here. Quickly check. Okay, I completely broke it again. I mean, that's interesting. Wow, how did that happen? Wow, really? No, you're kidding me? The cam speed is a float, the right axis is a float. No, are you kidding me? So the only thing I changed was that. Maybe I changed something else, did I? Yeah, no, but this was kind of breaking it anyway. Let's try it again. Try it once more. How could that be? How could that be? Am I stupid or what? Okay, interesting. Wow, how can that happen? Because, I mean, that should still work, right? I think you all saw it. It just worked 5 minutes ago. I believe I did not change anything, but I know. Probably I did. Okay. Wow. Now things get really interesting. This is kind of a interesting development. So why? I mean, this is essentially my strafing code. I mean, this should in any case work. No. I'm stupid. I know. It's not an or, it's an and. Because now if I don't pitch, I just don't do anything. Yeah. I think now it will work again. At least the part without the pitching. The part without the pitching. I mean, that should at least work again now. Yeah, okay, here we go. Well, at least this works again. And I guess it also works here. Yes, it does. Okay, good. At least this works. So now we can concentrate on why the pitching logic doesn't work. Why it doesn't work. Maybe let's just not do the strafing. Let's just only do that. And let's see if this is... if this is a problem. Yeah, okay, no strafing, but that's fine. And do we have up and down? No, nothing's really happening. I mean, I'm not sure actually about my VK up and VK down. Let's probably do some debug logging. Yeah. So is both working? Still working? Or why wouldn't it work? I mean, the reason if this does not work, no, but it does work. Okay, I mean, it just doesn't pitch at all, which is kind of fine, quote unquote, because it seems we didn't break anything. It just doesn't work. So why would that be the case? Let's think it through. We have the vertical direction and the vertical direction. Yeah, I mean, this is forward after the pitch. Yeah. This is, yeah, it's true. I think I know what I might do wrong, because actually I think the look, the look at target must be considering the forward after the pitch, right? I mean, if we want to look up, we are not interested into the forward vector after yaw, because this is just when we rotate around the up axis, but we are interested in the pitch axis. So I think this is the problem. I will just quickly check with also with the old code here, which I think is the one that you are still seeing. Sorry, by the way. I think yeah, it's so hard to show even one piece of code, and if you have a second IDE kind of open, it's hard to tackle around. So because now I'm quite sure that the location, the lookup target is the forward after the pitch. Yeah, that of course makes sense. So let's just get rid of the old stuff and just bring us back into the new one. And let's change that. And I think we should be fine, because now we have separated the looking to the movement. And this is the classical pattern for an FPS, right? So you look in one direction, but you move in terms of pitching, you still move on the floor essentially, right? Because unless you're Superman, you are not just fly where you look, but you just move on that plane. And yeah, but let's not talk too much. Let's just see if it actually works. But still, the theory is I think is correct in that. So let's see. Old functionality, yawing still working. And now look at that. Isn't that beautiful? Because now we can, oops, it's a little bit fast. But now we can also look down and see some more details. And yo, okay, cool. And I guess it must also work here. Oops. Oh, is it like, oh, okay. Ah, interesting. So it seems we're actually not moving in the, we're not moving in the, yeah, but I think that's what we wanted, right? We just, because now we are having flight simulator controls. But I think it's fine. I think it's okay for now. And as you see here, currently I do not have any steepness control. So the problem with that is if I'm too steep, things will turn around. So boop, and you see it's kind of, yeah, it's kind of not happy. And sometimes you're even then completely lost. You get this kind of division by zero effect, stuff like that. And yeah, one thing that I also note now is we have essentially created ourselves like a global variable in form of this camera, which is now shared between these different windows. So what we actually might want to do is to have a concept. I mean, let me think. We can, there is one train of thought which goes, we only ever have one active camera, yeah, because we do not have more than one 3D view ever, right? Because either we are in the level or we are here, or in any other model. And even if you have a lot of models here, even if we have many of them, even if you have many of those, there's still only one active, right? So that is one way to think about it. We could say, yeah, that's it, that's good, that's good enough. What we could also do is say every panel has its own little camera anyway, and we just store, yeah, this one camera per panel, and maybe that's the more clean solution. Because if you don't do it like that, that means that every time we have to kind of reset this one shared camera, which is also fine as long as we really stick with this one view. But then we could never have, for example, a split view here where the user says, yeah, but I want actually two perspective windows here. So yeah, just a quick thought and a sip of water here, because I think I will just go with the simpler solution for now, because normally that's always the good thing to do, and not to plan too much ahead. I think we will just do the minimum to make this work now. So we will probably go with the resetting of the camera solution. And if this feels totally ugly, we can do another solution anyway. Okay. Oh, my water is almost gone, but I think I will still survive. Yeah, I think this is now kind of broken. So let's do that. Let's think of how we do that. So let's say we are rendering the level editor. Then we are using that. So actually here is not the right thing to do. I think, yeah, I mean, it's a little bit unfortunate that we have this kind of check camera inputs. A function which is of course singular, that makes sense. Yeah, I think it's a bit weird if we really just have one camera, because we just have one place to check for inputs, obviously, and that will never change. That's just the way it is. So I think the nice way to do this actually is if we have if we had a focus concept, because that would mean that we have always one panel in focus, and this would mean that the first thing that this function does here, after collecting all the inputs, because actually fine, this is kind of neutral territory until here. You know, add checks. I mean, we can probably, this is even a to do. Add checks and pitch clamping, etc. So here we must update the focus camera. So this is a new concept. It's new. We don't have it yet. Because currently we are just essentially updating this one shared camera, right? So this is the reason why when you're in the level editor and you rotate whatever 40 degrees to the left, when you then go into the mesh editor, you would actually expect to be looking down straight in front, like the default with the default camera settings. But it's just not the case, because it's still stored in this one camera like setting. We need to change that. So now the next question is, how far do we go? So do we now introduce this focus concept right away, or is that already a little bit too far-fetched? Because I have a feeling in the gut that this is a little bit too complicated. So what we could do is, on the other hand, I mean, we need to get the right camera anyway. So how would you get it? We cannot guess it, so we must get it somewhere. So let's start with a very logically nice function that doesn't even exist, but we just pretend it would exist, because that would be nice. Now if we now say, well, give me the focus camera, the focus camera equals get focus camera, get focus perspective camera, and we pass it the editor state, because then we would say all of this is happening to the focus camera, to the current focus camera. Yeah. And then we could say, yeah, and then we could just, whenever we change the focus, which is currently just done with the tabs, there is no other way to change the focus. Check main tab inputs. Maybe not the best name, but it is what it is. And also we will have it to do here, because this is another ugly change magic constant. Just quickly write it down. Change magic constant. So actual side bar width, because that's what it is. It's fine for now, and the same for this. Oops. Oh, come on. To do change magic constant to actual top menu bar height, because that's what it is. So now this code here actually gives us the current hover top title. Yeah, that's fine. That's fine. That's fine. Okay, let's create this function. I think I have an idea now how to do it. I think we'll get there. So let's create this function empty, and I'm almost satisfied with what it did, but not completely. So let's see how we do that, because now we can actually look up the editor state, and we have the current hover main tab title. So this is the title of the tab which currently has the focus. So and now we just need a way to get the actual associated camera with that, and probably we will just do something like that. So let's say static boolean. I mean, it's now a little bit getting not so if we are the first time here, because what you will actually do, oh no, let's just, no, I think we will do it a little bit different. What we will do is we'll create a map. We will create a map which has a string as its key, and which has a camera pointer as its value. So we have now, this is the tab camera map. Okay. So what we need to do now, each time when we create a new tab, we need to create a new default camera. And each time the tab is changing, this is the camera that we will then use, and this is the camera that our input function will manipulate. Yep, that's what we're going to do. So now we need to, let's just write that code that already uses this concept. I would say we don't even need a first time here now. That's totally fine, because now we can say edit the state, and we have our camera, how do we call it, tab camera map. Yeah, that's what we call it. And we just return a camera, by the way. And we return the value for this key. And the key is the name of the tab. Okay, so the only thing left now is to actually fill this map with good values, right? Otherwise it wouldn't work. So let's do that. Where do we create a new tab? A new tab is created every time. At the moment, the only way to create it is when you select one of the imported meshes. So that means this must be check asset browser inputs or something like that. Perfectly fine. And we will, there's a lot of magic constants here. Just make one to do. And we will just do that probably in a cleanup stream. It might be a boring stream, but yeah. Or maybe I will do this off stream, because it's not interesting for you maybe to watch. Or we can also do a poll if I should do all these boring cleanups like publicly, and then everybody can enjoy it or not. To do, get rid of these magic constants here. So, but what I actually want to do is, I think the scrolling offsets actually, I think they are already accommodated for, but anyway. So we now need to check whenever we do a whenever we create a new tab, because that's actually happening here. So if it's a mouse left click, yes. If this is a mouse left click, we create a new tab, right? Do we? Do we? No, this is just the scroll bar. How do I actually do that? Here I do it. New tab. Perfect. And now it is the current. No, it is tab camera map. And we have now the name, I would say. Yep, the name equals a new camera. And the camera we create here. Auto camera equals new camera, and it is a perspective camera. I mean, that would be interesting because then when we later have other assets than models, for example, textures or sound, probably create an orthographic camera, because there we won't render any 3D stuff, but only orthographic UI stuff. So that's interesting in itself anyway. Yeah, let's see. And the camera, I think we can kind of reuse the init editor code where we have the basic default camera, which is here. And I'm just thinking if we should refactor this right away into a function so it's better visible. Yeah, I think we will create ourselves a new function. So we say auto camera equals create default perspective camera. Just create ourselves a small little constructor or factory function here. And I think we will need the editor state as always. Let's create the function, and it will return a camera pointer, and it will return a reference to the editor state, and it will essentially look like this, but not really, because we will just do it like this. And we will do it like this. And we will return it. This is just called once now. And what we'll also do, and I didn't find a way how to actually create the prototype out of this. So that's why I do it always in this super stupid manual way here. But I want a prototype so I can call it really from anywhere and not when I'm just below it. This is just stupid. So, and this is now actually the editor state. I mean, I'm not even sure if we still need it, but let's just keep it for now. This will be now filled in, and now we can actually reuse this function in different places, and we can also reuse it in the check asset browser inputs function. Inputs function, because now it's not any new camera, but it's create a new default perspective camera. We pass it the editor state, and yeah, we can even do it like this, because we don't really need it here now. And I think it might even work. Let's see. See if it does. Let's see if it does anything. Wow, crash. Cool. Okay. I'm guessing this is a null pointer now somewhere. Let's see where it crashes. Okay, it crashes here. Yes, yes, yes. Yes, 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 yes. Oh, it's in create default perspective camera. Ah, yes, yes, yes. Of course it is. Of course it is. I am using the wrong one. I'm using the wrong one here. I am totally using the wrong one. Yeah, I think that was easy. Let's just try that again. Let's just try that again. Oh, but I see it's so huge. It's so huge. It is so huge that I will make this a little bit smaller. Because I think let's find a good compromise. Okay, let's see if this still works now. Oh, now we have a null pointer here. That's good. And it happens at check camera input. That's totally fine because get focus perspective camera. Okay, and I know why. I know why. Because it happened in the level editor, and the level editor is the only part which is currently kind of artificially added as a tab. But there I don't give it a new camera. So we will do that now. And I think it's happening in the init editor. Is that the case? I think it is. Somewhere here must be a new tab created. Quad creation, grid creation for the level editor. Yeah, because it's a different one. Here it is. It's the level 1 tab. Yes, yes, yes. I think we will actually isolate it a little bit in a separate local scope. I just like to do that. So everything is much more separated from each other. Just makes sense. Now the thing left to do is editor state tab camera map. We need to fill it in, and the name is now level 1. This is a hard-coded thing, so in the future we will be able to create a new level tab each time we create a new level. And in our editor, there will be the option to have more than one level open. So this is more like in the philosophy of like how Godot does it with its scenes, then in comparison, I believe, than how I think both Unity and also Unreal Engine do it, because there you only have one map. You are always in the context of a map, and I never liked that a lot. I think it's kind of cool to have different levels, which is maps in my world here. And no, it's actually not a perspective camera, because we will create a new one again. We will create a separate one. Because now we should have hanging around as many cameras as we have tabs. Okay. Let's see. Let's see. Let's see. Let's see. Let us see. Okay. Yeah, interesting. I mean, it's not crashing, but it's also not working. Nothing's happening again. Okay, so I think we can now debug this, and we will debug it in the check camera inputs, because of course that's what we will do. And I think the problem must now be, oh no, I know what the problem is. I know what the problem is. The problem is that oh yeah, I'm seeing a I'm also seeing a new problem with the stretching and squashing and aspect ratio thing, But anyway, let's put that aside now. I'll just write it down in my physical old school notebook. This will separate cameras resizing issue. I think it's an easy thing because it will just iterate over all the cameras and then we will resize them. But it will bite us for sure. But I think it's an easy fix. Resizing every camera separately. Okay, that's what we'll do. I think it's better if I speak into the mic. Good. So what we have is this here, and the problem now is, of course, that we not use this camera actually in the level editor now, right? Because we now need to activate. Do we create or activate? I think we do just create. Yeah, create perspective camera for 3D panel. Yeah, I mean that's I think what we will do for now, and we will probably or very surely improve on that later anyway. So the width, I hate the editor state. So now let's say we have our, let's call it a panel camera. And what we will do now is to have this panel camera no, that's just not the right way to do it. No. I mean, the panel camera is fine, but of course, we still need to be in the correct tab. Yeah. So we get a camera, get focus perspective camera. Yeah. Otherwise, it doesn't make sense. And maybe that was already it, because now. This is a pointer, that's fine. I mean, let's just see if it works, and if it doesn't work, we'll just continue to debug it anyway. Not a problem. Not a huge problem here. Not an issue. So, and yeah, nothing's happening, so let's debug. Because I'm interested in which camera we actually get here. No, I mean, it should be fine. Should be fine. So let's look at this. This is the pointer with the address DF480. Let's write that down. DF480. Oops. So this should be now the private camera for the level editor. Okay, good. Now let's also put a breakpoint into our check camera inputs function, because now I'm interested in if this is actually the same camera that we are manipulating, right? Because if it would not be, that would also be a problem. Now let's continue here. Now let's hit. Okay, I mean, I don't. Yeah, the panel camera is still the DF480. I think we can get rid of that now. We don't need that anymore at the moment. So now let's hit the W key. So we move forward. Okay, we jump in here. Get that a bit out of the way for you. So now the question is, what is the focus camera? And which address does it have? So the focus camera, yeah, okay, I mean, that's fine. That's DF480, yeah. I mean, that's good. That's That's good. And now we actually, the location is already changed. It was 6 and now it is -5.983, whatever. That's actually fine. Update and get view matrix. Yeah, it's all, it's looking good. Yeah, it's looking good. It's not looking that bad. It's actually interesting why it would not work then. Then let's go back to rendering the lever, because I guess, I mean, we can check what the location looks like. Is the location correct? Or maybe I'm, I think I know what's probably happening. I think I know what's happening. Or is it? Yeah, I think I know what's happening. What is happening is that this panel camera, I think, is perfectly fine, and it has, so it is the right one, it's the F480, and it also has the correct location. Okay, why does it have the correct, oh, so this location never changed. I was not expecting this. So what I was expecting is to actually have so what I was expecting is to have it correctly here, and then essentially override the shader with the wrong camera, which is kind of being set up here, because this is just the standard default perspective camera, which is shared and is totally weird and totally wrong. But the funny thing is it's already wrong at this point here, because you see the location is wrong, because the location must be something like -5.9 in the z-axis, but it is still 6, and 6 is the default value, which doesn't really make sense. Doesn't make sense. That's funny, huh? We will do two things. I think the first one we'll do is render each game object. I mean, that's nice. The post, does the post move? No. I mean, that's probably also an issue here. Which camera is used here? Yeah, there's, okay, yeah. Yep, yeah. Yeah, okay. Okay, let's see. Let's just get rid of the grid, so if that changes anything, because I think it should. Like in terms of, no, but still nothing is moving. Oh, is it? It is actually moving, isn't it? Yeah, okay. You see, it looks like it's always reset. Okay, it seems like somebody's resetting the location and everything else as well. Yeah, I'm probably doing that somewhere. Stupidly enough. So, what is the best thing to do here? I think the best thing to do is to not directly manipulate the properties of the camera, but to just have probably a kind of a setter function or something like that, because then we can much easier debug inside of that. Yo. That's what we could do. Or we just think it through as well. I mean, we can focus on the fact that the camera is already wrong. So somebody maybe at check camera inputs. So maybe we are already kind of resetting something for whatever reason. Oh, I mean, I see that this is okay. This is also already an issue. So we must put that here actually, because here we are already referencing the wrong camera, because now we want the focus camera here. This must be the focus camera. Yes, it must be. Oh yes, it must be. But I think that would not change actually our issue. Because the funny thing is that we are here and we are setting a different location. So who does set the location? I mean, that's actually, I think we can just try to find that. Unfortunately, it's more than one location. So I think here is not the problem. It must be one of these three, right? I cannot. Yeah, or here. It's one of these four, I think. Yeah, I think it doesn't help. We need to visit every function here. So yeah, let's start with this one. Create perspective camera for 3D panel. But I think nobody's calling that actually. Yes, okay, that's fine. Let's go back. Who is calling location? So this was the first one. Perspective camera location. When is this done? This is done on resizing, I think, yes. I mean, it's okay, but I think we do not I think we do not call it unless we are resizing, right? So it's at least what I think, but we can prove that later. What is this? This would also reset it, but this is the frame buffer specific camera. Okay, I mean that's for a very specific scene. I think that kind of is okay. It doesn't count. We don't call that now. That's fine. That's fine. Where have we been? I think this was it. So now let's see. Create default perspective. Okay, this is the default perspective camera, which is called a few times, but I think only once, right? So yeah, I mean, this is once called, and it only counts here anyway. And here it's called, okay. And here we have been already. Yeah, this is not writing to it anyway. I mean, this is just something. Yeah, this is just a thumbnail camera. Yeah, I am not totally sure right away why that would not work now. This is kind of interesting. Let's think of some other way to do it. I mean, if this is the camera, I mean, we know it's level 1, right? So this is our camera here. And it's level 1. And if we say render, I mean, I've already checked actually. I mean, this is, yeah, I mean, let's just debug it once more. I think it's fine. We will just find it out for sure. Check camera inputs, and let's again do this, because here we have the location, and then let's compare. Yeah, let's do that. So I am hitting W now, and then we should land in our breakpoint. Here we are. So the old location, sorry, is -6. The new location is something like -5.9, whatever. Yeah. Okay. So, and the focus camera's address is C740. Okay. C740. Good. Good, good, good. Then let's just press that again and let's see if that already changed here. So the old location is, yeah, it's fine. And the new location is a little bit smaller. 9855, and the old one is 9851. Yeah, whatever. Okay, I mean that's fine. So then let's go into the render level function again. And what is this panel camera now doing? It is, first of all, is it the correct one? Okay, so the new location is, oh, look at that. This look, oh, huh. Oh, I think, no, could that be the case? Where does the, no. Where does the location come from? Oh, yes, because I'm just stupid. Yeah, it must be the focus camera. That might have been it. Everywhere we use the camera, we need to use this focus camera and not the default one. Let's do this once more, and I think it will work now. I think it will work now. Let's see. Yes, much better. So now if we introduce the grid, I think it will break again, because the grid essentially overrides our nice camera setup here. But it should be not so hard to fix this. Yeah, I mean that's what you expected, and this will also now not work. Okay, fine. This was expected. So the render grid must actually do something very similar here. Yeah, and that's perfectly fine to do that. And we need the correct camera, and we will just use the panel camera now. And maybe that was already it. In the good case, it was already it. In the bad case, it was not. In the bad case, it was not. Let's see. Here we go. And we can also fly around. A nice little grid, and we can also go down. We can even dive under, right? And then we can look up. Isn't that nice? I don't know where the guy is, but I think here he is. Let's fly up a little bit, fly down, go here. Okay. Let's try to find it. Let's orient ourselves at the post. Look up. Cool. Okay. Yeah. Quite some distortion going on here, but it's fine. So the next thing that will not work now, I guess, but we will just do our unit cube for that, because that's easier to see. Yeah, and oh no, yeah, we can actually check now. So here we are in the front, which is already probably a good sign, because we are not in this kind of shared view anymore. So let's here go to the right a little bit. Here we're still in the center. That's nice. Here we're also in the center. Here we go to the left. And if we switch now, we still have the correct cameras. Isn't that nice? Isn't that nice? Let's probably create a fake third person view just because we can now. Just because we can. A little bit like that. Maybe a little bit up, a little bit down. So now, kind of like, this is probably how our top-down bullet hell shooter will have its perspective. A little bit like that, maybe. Yeah, we will see. Yeah, the camera definitely needs some more polishing. It's not the best experience currently to handle it and then to use it. It's not so nice, but getting there. So what I actually wanted to demonstrate is if we go to the unit cube and we put ourselves more or less in the middle. One thing that I already immediately see is that we have again lost our resizing, and it's anyway wrong, which kind of makes sense. And if we stretch it, that will be even more apparent. But I need to show you, of course. So if we stretch and squash, we see that this is not correctly resizing, right? So this is just stretching too much. So yeah, and you also see here, I mean, the problem is, I think, in general now that yeah, I think, but that's actually okay. Yeah, interestingly we have a second level, second layer of distortion now within the streaming software, but yeah, trust me on that, it's just not correct. So we now need to also, I will put that back in its place probably. I'll make it much smaller. Maybe like that. So, yeah, so because this is actually how it looks like now, and we will move it right here. Okay. So the aspect ratio problem is back, because the important aspect of the issue is actually that we just have the wrong. Oh, hi Compa, hi, nice to see you back again. Hope you did well with your C++ experiments in the meantime. Good to see you. So we have now the wrong camera actually updating the correct projection matrix, stuff like that. So it's actually kind of two problems now. The first one is that it's not correct kind of right away. So it's wrong right from the get-go, I believe. Let me just quickly measure. I mean, already my just by eyeballing it, it looks wrong, and I just had a screen. I just used the screen ruler, and it is wrong. Hey, you're already jumping to assembler. Wow, very quick, very good, very good. Yeah, well, I think we will also do some assembler on this channel one day. Then yeah, we can also talk about that. But today we have enough on our plate with with the C++ magic here. So let's pull these threads in the correct way. So what we need to do is, now we need to be aware that the actual projection matrix needs to be updated as well, right? And I think that's currently the problem. I think what we're currently doing is, if we say render the level editor, if we are rendering the level editor, we are getting the focus perspective camera, but I think this camera never really gets does it? It doesn't really get the correct. Yeah, it's, oh yeah, I know. It's actually never really updated with the correct aspect ratio. I think that's a problem because we create it only once. We create our default perspective camera. That's nice. That's not wrong. This is not wrong at all. But this is the problem here. It's mainly this, because the view matrix actually gets updated anyway by means of our check input. But we do have a problem with the projection matrix here, because here we set the view matrix, but we do not set the projection matrix. And the question is, should we just do this here, or so what is a reason to do it here is that we are essentially manipulating the camera here, right? So why not do it here? On the other hand, we are not really dealing with any projection stuff here, so also doesn't feel completely right. I'm just moving this comment here. You must update. So let's put it in another way. Everything camera related must happen to the actually. Hey, cool. Hey, your terminal already understands 3 commands. That's very good. Congratulations. You're doing good. You're doing good. Very good. Cool. Must happen to the current camera in focus. So that's how we grab it here. Cool. Well, these are very important commands, right? So you have exit, clear screen, and help. That's pretty good. And help already prints out real help. Is that what it does, or is it more like a placeholder command yet, or is it already kind of helpful already? So everything camera related must happen to the current camera. So because I'm just thinking, so if we would now say focus camera. Oh yeah, very good, very good. Thumbs up. Very good, very good. You're in a good way. On your way to your first terminal, I guess. It's cool, and maybe it will be such a cool terminal application that we will all want to use it in the future. Cool. So if we want to update the projection matrix here, update and get perspective projection matrix. I mean, you could just do it. 65 is currently the field of view, the width and the height. No, we cannot do that. No, we cannot do that here. We will just not do that. No. We must do that for each and every panel because we have no idea the size of the panel, stuff like that. Yeah, okay, I see. Oh, but still, I mean, it's fine. I mean, really, just don't forget, make small steps, one step after another. And, you know, if you take a lot of steps in the right direction, you go very far. So, no, it's fine. It's good. All good. It's all good. So we cannot do this here. So we must do this in the actual panel, because then we know how big the panel is. And I mean, yeah, we could do it in resizing, but this is not enough. So we need to do it in all the places where we actually render 3D stuff. So we do it in the level editor, and we also do it in the mesh editor. But let's start with the level editor. So the level editor has the panel camera, and now we will actually update the panel camera with the latest perspective matrix, because now we do 65 for now. We do width, we do height, and we go to our standard plane things. Okay, let's try that out quickly. Yeah, that's very good. So you will make it its own rendered program. Super. Very good. But I guess that's some steps away, but that's fine. That's fine. Just take your time. It's better to work like every day on it for a short period of time than making a break of 2 weeks and then trying to work 8 hours or something. It's just try to work on it like really every day if possible, even if it's only short. That would be ideal. And if not possible, then just try to make not too long of a pause, because it makes it so much easier for you to keep everything in your head, and then it's also much more fun to work on it. That's also why I try to work on this every day, even if it's only 1 hour or 2 hours or whatever it is, or maybe even less, but I still try to work on it a little bit, because then you always keep it present, kind of. And that's very nice. That's very practical to do. Okay, so we will now try to see if our does this work now. I think I must do it better in the mesh editor. Render the mesh editor, and we will do it here as well. So we have our, okay, we don't even do it here now. Okay, anyway, so let's just do both, hit both flies with one strike. We have the panel camera, we get it, and then we update it. Panel camera update, get perspective projection matrix with height, and sorry, the first one is actually the field of view. It's the width and the height, and it is the near plane. We set this to 0.1 and to 100, and we need to use the panel camera here as well. There's a lot of camera stuff, but I mean it's kind of normal. Okay, and the wolf script, this is then kind of your own language. So this is your own invention, right? Wolf script is your own script language, right? Sounds cool. Wolf script. It's cool. Sounds very dangerous. So yeah, let's see if that works. So we will now load our unit cube, and we will then see if this unit cube actually, no, this is not what I wanted. No, come on. No, that's not what I wanted. That's not what I wanted. But it is a test in itself. So I think I need to show you the editor much better. Okay, let's have a realistic size of the editor now. Let's put that here. And I think I'm quite happy now. That looks already much better. Yeah, I think we have the basic operation is working again. Now let's see if we stretch it. I think it's still working. So the problem is I see it now in the stream. The problem is with OBS, it's not correctly actually kind of showing the correct aspect ratio in the OBS, but on the screen it's fine. I will try to look this up, how I can change this. I mean, so you're asking, can you code with the Windows API in CPP? Absolutely, you can. I assume you mean the Win32 API, because that's the more natural one for CPP. If you mean with Windows API something like that is normally used in C#, it is possible, but it's not like the raw unmanaged C++, how it's called. And you need to have a specific Windows flavor of C++, which I personally am not a fan of, because it's kind of half managed, so to say. It's a little bit weird. And then you could also use that. Yes, Windows Edge is there. I mean, I use it. I can show you. I can just show you after this test, which anyway looks fine. I think we're good there anyway. I can quickly show you. I can show you in a second. I can show you in a second. You actually need to use Windows Edge for everything I do here now. So the most important function that uses Windows Edge here is this one. See, this is a file I wrote. I called it the Win32 window, because actually the engine is planned to be also working on Linux at a later stage. But currently I'm only working on Windows 32. And like Windows 32 is just the name of this classic API. It's still a 64-bit PC, but and I think you see, I mean, there's actually Windows X here, which I think in itself uses Windows Edge, and I think I also use it probably here, I guess. Where do I actually use it? I think here I'm not using Windows X, because it's essentially using, I think that Windows X is already, it's maybe here. Yeah, here for example, so here's Windows Edge. So here in Windows Edge you have all these, as you correctly called them. I mean, this is just a short version, I guess. So, and Windows Edge also is mainly like a master header, which includes a lot of other stuff. But yeah, here you have all the Windows API function headers and basic type declarations. Yes. And the second question, if I specifically know how to code in it, yes. I mean, for example, so normally you try, I mean, is it true what I say? I mean, I will say it anyway. You try to probably keep this as little as possible, like that you have to deal with this specific Windows API, especially if you want to be cross-platform. So if this should also run in the future on Linux or on Mac, then it is more practical that you do not use too much of a specific operating system, right? But nevertheless, there is some things that you need to do, that you must do. Yeah. So I will not go into too much detail, because this is a 3-year course in itself, probably, just to go into Windows programming and the Windows API. But I will also give you a book recommendation. It's a very, very old book, but this will teach you, if you're really interested in that, this will teach you it. And I will write it in the chat. So this is the author. He's called Charles Petzold. And I think it's really called Programming Windows. I think it's really just called that. Or very similar to that. This is like the classic book about the Windows API, right? But what I wanted to show you quickly is just that you, more or less in this file, this is really all pure Windows API code. And the most classic thing that you would also need if you want to render your terminal in a separate window. Then what you must do, but I really will not go into super detail because this is really like very broad knowledge. Then there's so many also kind of exceptions to the rules, stuff like that. It cannot easily be covered here now in any useful way. We could probably do a complete series of streams just about that, and I could do that. I mean, I've done this quite often. But anyway, just to give you a small overview, essentially there is, I'll probably even start here because there is one thing that you already know. If you're making a console program, you know there is an important function called main, right? So main is the one function that the operating system actually will jump to when you start your program from the terminal, right? So you know main. Main is true for console programs. There is a similar thing for a Windows program which actually renders a real window, and this is called WinMain, right? And so this is kind of like, you can imagine, like this is it's a little bit like a magic function. I mean, it's not really magic, but it's really every piece here is important. So you really have to call it that. So this is a specific symbol which indicates to the compiler, okay, this is really now a function that is meant to be the main function for a real Windows program, not just a console program, but a real windowed program. So everything starts here. So this is where in my editor main, this is the first thing that the operating system will call, right? This is the first thing that where it will jump in. And then it gives you some additional information. It also gives you some parameters, which most of them are very cryptic and I don't even use them. That's why I didn't even give them names here, what you see. And then the next important function is actually, I've buried it in my own little class, which I called Win32 window. But this is now what you will see in a lot of tutorials online, which you will see in the book of Mr. Petzold and in a lot of other sources. So this is like a very lightweight and a very simplified but still efficiently working way to create a window, right? So if you have this code here, essentially what it does, you first specify how the window should look like, essentially. So you do that by filling out a so-called window class structure. In that case, it is of type window class extended. And the W stands for white strings, but it's just, I'm also mentioning this because there's a lot of details. There's also a function without a W, and then it goes into non-white strings, and it gives all other kinds of headaches. But anyway, suffice to say that here you are specifying certain behaviors of the window that you are about to create. And one of the more important things is this window procedure, which we will come to in a moment. But you also have to give it like the instance of your program. This is something that you get passed by the operating system. You don't need to take care of that essentially. You just get it passed in and then you just add it to the specification here. You have to give it a class name. You can load a specific cursor. For example, here this arrow is just a normal arrow that you normally know from Windows. But you could also start with a specific with a different other arrow if you want, because here, for example, what you see now, and I think you also see it on screen, yes you do, this is what is it's more like a cursor. I mean, it's looking more like it has this one vertical line and the two horizontal lines. Then you call a window function. So this is the first real, or this is the second window API function that you know. So we have WinMain, but we also have register class X. So where is this? You see, I mean, it's kind of in WinUser, which is just one of those sub-files of Windows H. And so there is no implementation there because Windows is not open source, it's closed source. And most of the API is yeah, you just can jump into the code. There is some parts of it where you can a little bit see what it does, but not the real deal. But this is, for example, this is part of the Windows API. This function here, right? So this is not written by myself. You can call it. The linker will make sure at runtime that this function is callable to you, and so you must register your specified window class. After you have done that, and here I have fortunately written a nice comment, so I can just rely on that. I'm adjusting the window size because, as you know, a Windows window has a top bar normally. This is not mandatory. You can also create one without, but in my case, I have it because now it's more convenient for an editor to have this feature. And there is just this is the next Windows API call. It's called adjust window rect, also not written by myself, and you also see it in WinUser. So a lot of API functions are actually not in Windows H, because, as I said, Windows H is more or less the master file, which mainly just includes other stuff, and a lot of the things that a user might call a developer here in that sense, a developer that writes a Windows application would is to be found in WinUser.h. Okay, and as you see also here, I hope you can see it now. You cannot because the pop-up doesn't show up, but this is part of the so-called Windows kit. It's just normally when you have installed, I think, Visual Studio. I think it's not part of just Windows itself, but if you have the real Visual Studio, not Visual Studio Code, that would not be enough. But the Visual Studio, there's also a free edition for that. You would get all these files and all the libraries for that. Okay, yeah, so we just decide for the correct window width so that the dimensions that the user wants the editor to be, that the user really gets these dimensions, and we calculate how big is this top menu bar, so that the window that we create is actually big enough that the actual net area is actually the one that the user has set up here. So if you want a window like that with 1280 by 720, then this would be the necessary calculation that we need to do, because now we have this window height and window width, and now we have one of the most famous Windows API functions, create window X. So as the name suggests, and as expected, again, it's defined in, or it's declared in WinUser.h, and the actual code you would find only in binary form in one of those Windows DLLs. And here is the actual window created. And essentially we pass in all these parameters, and so what we get back from the Windows operating system is a so-called handle to a window, and it's very common to call this HWND, handle to a window. This is really like the common canonical way to call this, but you can call it whatever you want. And here we make a small check. So did we actually get a non-zero handle back? And if we do, we show the window, again, another Windows API command. And this is actually kind of very telling, right? I mean, what does it do? It shows a window. That's what it does. And then update window. And update window kind of asks Windows to actually run this kind of internal message pump, because you might or might not know, but it's like Windows as an operating system really, of course, manages every window that is currently active, every program. And a Windows program actually technically has normally a lot of windows, because in Windows operating system terminology, essentially everything you see on the screen is a window. So for Windows, a button is also technically what it calls a child window. Every piece of text is a child window. So every program technically for Windows consists of a lot of windows. It's hard to talk about this when the name of the operating system is already Windows. But update window kind of starts this whole update loop. So the operating system then knows, okay, this program is interested to receive updates, because otherwise you wouldn't even get an event when the mouse is in your program, right? Or for your case, if you're writing a terminal, you're very interested in keystroke events, right? So without that, you wouldn't get these events. Okay, then this is just more graphical stuff for what I do here. But what I mentioned before, and let's just quickly go there before we leave our Windows excursion. But what is very important, so I told you now that this you have to tell Windows actually please send updates for my program, okay, and send updates for all of my first, second, third level windows, okay. And you do this by giving essentially what is normally called a callback function. So you tell Windows, hey, look, when there is an update regarding my program, this is the function I want you to call, okay. And what is this here? And this is the parameter. So you tell it essentially, this is a long pointer to a function to a window procedure. And we give it this cryptic thing here. It's called wndproc. This is written by myself, and you would have to write this also for yourself. If you want to write a Windows program, this is what you need to provide. And this is more or less the heart and soul of it, because you will never call this. I think technically, of course, you could, but you should not do this. This is called at runtime out of a DLL directly from the operating system, essentially. Yeah, so you will just get called from somewhere in the universe. That's how it looks like from you. So the operating system will call you every time when something happens to your window, and something's happening is just already the mouse is moving through your window, or the keyboard was struck when your window was in focus. So it was the active window, okay? So how does this work? This function is called, and you see it only gets a handful of cryptic parameters. So it actually then tells you the exact window, because as I said, you can have child windows. So you can also have one function that gets the events for your main window, but also for every button window. And inside this function, then it's actually kind of quite logic. You just do a switch on the actual, what is called a Windows message. So this is kind of another name for the actual event that you get. And then you just say, okay, which kind of message is this? Which kind of event is this actually? Was there a system key pressed? Was there just any key pressed? Was a mouse movement? So I think that's actually kind of understandable. It's quite nice. So Windows gets a lot of criticism for its API, but yeah, I think a lot of it is probably well deserved, I guess, but it's also not everything is bad. For example, if this is the message, what I'm doing here is I'm just storing it in my own little variable, and then I'm giving it to the actual game and editor layer, right? Or for example, this is the magic behind the resizing. So I'm also listening to the so-called WM size, and WM is always standing for Windows message. If I get a size message, I pull out the actual new width and height, and that's essentially it. And there was little special cases. So this is the point in time when the resizing starts. This is when it ends. So there is some room for improvement here, because actually what I'm doing here is not the ideal thing, because this WM size is, so if you do a resizing by 10 pixels, I believe you get actually at least like 10 messages for every pixel along the way. So this is not so efficient. So what you could do is you just like make yourself ready for resizing when this starts, and then only when it's finished, you just actually pass on the last value of the resizing to your other layers. This is just for the left button double click. This is for the left mouse button click. Or essentially it's even more fine-grained, and this is really cool for drag and drop, for example. So you get a message from Windows when the left button is held down, okay? And as long as you do not get an up message, you can actually rely on the fact that it will still be pressed down, stuff like that. And you also get these kind of messages. So when the Windows is destroyed, I believe this is, for example, when you hit the close button, this is the message that you would get, okay? Have you ever coded on Linux? That's a question. Yes, I have quite a lot, but not so much like desktop or Windows. And applications, but yeah, more like just typical console application stuff like that. My renderer uses essentially, I think, 3 or 4 libraries I can show you. One of the library is actually, so one library technically is glue. This is the code of glue. I just copied it in here. Glue is very specific to OpenGL, which currently is not my active renderer, so I will not go into detail, but I will just give the quick information. Glue is needed with OpenGL on Windows because OpenGL on Windows, let's say, is not a very natural citizen. And so you need these kind of helper libraries to really be able to use the latest versions of OpenGL under Windows. There is other alternatives as well. I'm just used to Glue. So this is one library. It's very specific to OpenGL. I'm not even actively using it now. Another one is, well, there's 2 or 3. Another one is these 2 here. So this is these are just open source from GitHub, and these are so-called header-only libraries. And I love these because a header-only library is what the name suggests. You just use the header. You just put it somewhere in your code base. I just put it here, right? And so this is these are actually 2 very kind of, or rather famous libraries, so to say. One is called STB image and the other one is STB TrueType. So they are both from the same guy. He's a very, very, very good programmer, much better than I am, of course. He's called Sean Barrett, and you can just look him up. This is just, there is a GitHub repository where you can find all these files. And there's also some quite nice explanation for that. But the trick is, so to say, that everything is really just in one header file, actually. So you might now ask yourself, yeah, but if it's a header file, I mean, normally in a header file, I don't put actual code in it. I mean, I just put declarations in it, right? I mean, how can this work? And the trick is here, it's a little bit down. It's actually even written here. I was already there. I think now I screwed it up. So let's search for it again. I think it was called end header file. Yeah, here we go. Look, so this is the actual header file here. It's 500 lines. And now, so the trick is, it says if there is a macro definition which says STB image implementation, then here follows the actual code, the actual implementation, right? Let's just go there, and here you see it's actually just implementation. This, for example, is a library which helps to load images in different formats, which is just a little bit of a pain in the ass to do. Like, for example, if you want to be able to easily load PNG images, but also JPEGs and bitmaps and what have you, then this is just a very nice library. So how does this now work? How does this definition work? The trick is also described here in its documentation. Do this, you just make a define. Okay, that's easy. But where do you do this? You should not do this in another header file because the header files might be included several times. This is a problem. You just include it, as it says, in one C or C++ file to create the implementation. I believe I do it here in my absolute one and only main file. Yeah, here I do it, for example. I do it here. Because every macro implementation, every macro definition, is just picked up by the compiler. The compiler will remember it, that this is already defined now. And the next time, if it sees the STB image.h, I mean, I should probably do it like that. That makes it a little bit easier to read. For the compiler now, because if this is only defined once, then this only also comes essentially like once before the actual header file. So now it will see this definition in this file actually, because as you might know, the C compiler does a pre-compilation step and it just expands all these header files and essentially just makes one big file, and it really rather stupidly, you could say, or rather simply copies all the contents of these header files into this C++ file here. And in that case, when it then reaches the STB image code, it actually has in this compilation unit the actual implementation. And so from this moment on, it kind of knows where the implementation of all these STB image functions is. Now this was just an incursion for a header-only file. I can only recommend it. It's just much easier to use. And there is a similar one, the second one, which is also from Sean Barrett, and it's STB TrueType. And this I use for parsing font files. And this is the basis of text rendering. I will not go into full detail, but it's also very practical. It is able to read so-called TrueType font files like what I have here. And there is a lot of resources on the internet where you can get legally very nice and very interesting free fonts. And you can just then download them and load them with this library. And what it does is quite low level anyway. It just, it does a lot of very cool stuff, but there's still also some work that you need to do. But what it does is it can understand and parse the TrueType font file, and it will render every glyph, what it's called, or we would also call it a letter like A, B, C, D or whatever, or a colon and a comma, into a small little bitmap file, which then you may technically use as a texture. And then when you actually render some text, this is very important for you. Then if you really want to render text as a terminal, this is your bread and butter, then you would then just also use the TrueType library. You give it the text that you want to render. And then this TrueType library can give you kind of a neutral geometric description of how this text would look like, because it will give you small little rectangles for each letter one. And this then you have to, again, to process into DirectX, Vulkan, or OpenGL, or whatever render you do. You could also, of course, do a non-accelerated renderer. You could do just a pure CPU software renderer. But this is what you would need to do anyway. So you would need to translate this information from this library into, in my case, I'm translating it into DirectX 11 kind of lingo, and then I'm rendering my text. Okay, and there is one more that is very important that might not be so important for you if you're just doing a console terminal application, or if you just create a very text-oriented program. But if you are doing game programming, or you also want to write your own engine, there's one library that is very important that is called simp, and I will write it in the chat. simp, a library for importing models, e.g. from Blender. Okay, and unfortunately this is a rather big and more complicated library, so it's not existing as a header only. So this has to be built separately, and I've downloaded it. It's free. So it's royalty free, and also the license allows you to use it in your own game and engine and stuff like that. And you can also still sell your game. That's all not a problem. But you have to build it into a binary form, into a real library, and then you have to link it. And I'm doing the linking here, but so here it's also mentioned. So yeah, essentially you just have to tell it, okay, where is the simp library directory? So you have to give it this this directory as a variable here. So I made it this way because this code actually is open source. So anyone interested, you can just go to GitHub and you can just download the code. So I will just commit the latest state in whenever I finish my stream here. And then you could also try to build it and use it actually. And you would just need in your cmake command to just give the correct variable name where your simp library directory is. So you still need to have simp built on your local machine, or you have somewhere obtained the library for your operating system, which currently must be Windows anyway, otherwise it wouldn't work. But then you just give it as a library, and then it would take care of the linking and also making available the simp header files. And how this is used, I can just quickly show you maybe. Here, it's part of my renderer DirectX 11 code, if I'm not mistaken. And it's, oh no, I think it's actually in the common probably. Is it common? No, let's see, where is asimp? Yeah, it might be in the common code actually. Import, is it loads, model, mesh. Where am I doing it? Render text. No, let's see. Where is asimp really used? Well, let's jump in where I actually call it. So I think it's called import model by file name. Okay, let's see. Import mesh from file. Okay, no, it's it's here. It's the asimp mesh importer. Okay. So for example, this is my own code, but I'm using here the library, and you see here that I'm including some of these asimp files. So I need the actual importer HPP, I need CNH and postprocess, and what I do here is I use this typical C++ idioms here. So this is an asimp method, for example. I'm reading the file, and then it's quite some code. It's still quite some work for you to do, but without asimp it's even worse, because then you have to be able to parse for yourself all different kind of model formats. I'm still using only GLTF anyway, but it's still, I've also written an importer myself that directly parses the JSON out of it. Yeah, but then I switch back to asimp, which I already knew, because it's just simpler, and yeah, it's not so interesting to write these kind of model loaders here anyway. Yeah. Hey, that's a wonderful progress you make, because it's kind of like a main breakthrough when you can already use your own yeah, in that case terminal, and your own command language to print something out. That's cool. So we want to achieve here, or I want to achieve the same here with my, or similar thing with my editor. So it would be cool when the first time we really run our own game in our own editor, right? So that would be nice, but that will be probably some streams away, but hopefully not that much. So, okay, I hope that excursion helped a bit. I hope that helped a bit. So let's see where we are now. I want to check, does this still work? Yeah, it still works. And yeah, that also still works. Okay. Cool. Yeah, but this is essentially all the libraries for now. I think there will not be so many other libraries coming in there. I mean, let's see. Currently sticking with that. The animation code is all by myself, so there's no library for that currently. So, but yeah, let's see. Maybe we will use another one. Ah, yeah, and there's one library that is very important that I have forgotten. Sorry. It's called GLM. And this is essentially, it's like a mathematics library, and I'm using it for all my vector and matrix calculations. When you do these rotations, everything I do with the camera to actually being able to rotate and do the projection matrix, this is all done by GLM. This is just, yeah, it's very convenient to do this. And yeah, you can write your own vector classes and your own matrix classes for sure. It's also a good learning experience, absolutely. It's just, yeah, I did it several times, and it's also not that interesting. There is learning experiences and learning experiences, and some of them you find more interesting, and some of them you don't find so interesting. So I tried to get back on track what I actually wanted to do before. What was it? If someone knows, please help me. Otherwise, I will try to find it back by myself. What was it? What was it? What was it? What was it? Start it again. Maybe I will find out what I wanted to do. Is there something really kind of wrong? Quickly check. I mean, it still works, right? So still here. It's fine. Ah, yeah, no, I know the stretching. I think it was the stretching problem. Yes. Because we have these separate cameras now, we still have the problem that the stretching is not correctly handled, right? Yes, it is. Yes, and yeah, I think we see it best with the cube. And if you go to the cube, so it is stretched. The problem is, or is it? No, it's actually working now. It's funny. Ah, yeah, it might be because, okay. Did we solve that already? Now I'm confused. Because it actually looks good. It actually looks good. Did I solve that? Can't remember that I solved it. Really? Already with all the cameras? Or maybe I did. Maybe I did. Maybe I did. Maybe I did. Okay. Good. Now let's see. Good. Good. Okay, so I'm thinking of what I could tackle next. There is a lot of things to do. The question is, what is the best logical next step? If we assume that very basically these kind of interactions now work, so we have separate cameras per viewport, so we can look here like this, and here we are still looking completely differently. That's fine. Yeah, okay, that's a good milestone. 1,000 lines of code. That's already a very good number. Yeah, I mean that's totally cool. Totally cool. So I think what might make sense is to really kind of bring the actual level editor to life. So what is missing here is two things. I mean, it's probably 1,000 things missing, but like very obviously there is a function missing to actually add new game objects. Okay, and what I think should happen is, so either we just put it here, which is a little bit similar to how Unity does it, but I think it's okay. We can do it very, very similar. So we just need to expand on this menu here, and then we would just say, well, there's different kind of basic game objects. If we go along this route, not totally sure about it. Another way would be that we have here this actual game object tree, and we just add a kind of like a button, like a plus button here, or we have a kind of like a pop-up menu here, and so that's also possible. Everything kind of makes sense. I think we just need to decide on one of the options to start with. I'm just thinking which one to start with, which kind of makes sense. Let's probably expand on the menu here. I think regardless on what we do here, it will be quite some work to do anyway. So in terms of, might not be a quick win anyway, but let's see how far we come today, and yeah, just go from there. Yeah, so then let's go down the game objects menu route, and what that means is that in that case I need to be able to render a drop down menu essentially. So this we will now invent from scratch essentially, and let's plan this a little bit. Let's think it through. So what must happen? The first thing that must happen we can already do, because we already know, obviously, that we are over the game objects menu, because otherwise we wouldn't see this effect here, right? The second thing that must happen is we must recognize if it's clicked, and this is generally already also possible because I can already do it with the import menu. So that should be quite easily to find out. So I think this is more or less the easy part. So then when it gets a little bit more interesting is when we actually have to render the actual drop-down menu. And if we break that down, what is happening is essentially when our mouse is over the game objects menu item and the mouse is clicked, we need to render in the correct position a rectangular region in a certain color. I would say the color should be exactly the same gray as here, so because then that would make everything look rather coherent, I guess. And making that a little bit smaller maybe. So what you would like to see is a gray rectangle then dangling here below this menu. This is the first step. Let's write that down. You can even write it in our editor here. Let's just create a new note. Creating a new note. It's a new text file. We call it notes 180725 MD. And which is notes 1807 2025 rendering, or let's call it creating a drop down menu for game objects. And or probably this is more like that. And render a colored rectangle below the actual menu item. That will be our first task. After that, if and when that works, we can render the actual game objects sub menu items. And then finally, but I'm quite sure this will be at some point in time and not today, bind actions to the actual submenu items. And maybe this is kind of a bonus thing, but I think we will need it anyway. Enable child submenu. So essentially it's like a tree of menus. I think it doesn't really make sense from a usability perspective to have too many nested tree-like menus, because I think the user gets completely lost at some point. But I think we should have at least the ability to have 2 layers, maybe 3. And anyway, so we need a generic mechanism to enable that. So that's fine, I guess. Okay, so now we have a task list. Now let's try to work on it. Let's try to do something. Good. How do we do that? I think we will go into our check menu inputs. So I will probably now write some comments here. So this, what is this? This function handles currently only mouse input. No, it actually checks if the mouse is over one of the menu items. Currently it's only one of the top menu items actually. Because in future we might have also kind of like temporary context menus that are floating around somewhere, especially also in the 3D viewport maybe. So you right click on a 3D object and you, whatever, you want to deactivate it or you want to do stuff with it. So it might be different menu kind of modules, but currently we only have the top menu anyway. So if the mouse is over an item, the item is rendered, the item is marked as being hovered, because that's exactly what's happening, because now we are not rendering anything here in that function, but we're just telling the rest of the system, hey, just that you know, whatever the third menu item is, actually the mouse is hovering over there. And this is how in the rendering code, and I'm looking at this, is do we have an item that is actually currently hovered, and then I'm rendering a separate color underneath. This is how this magic works. And if the mouse is clicked over an item, we call an action that is bound to this menu item. And currently the only action that we have kind of bound in a hot fashion is the import action. That seems unnecessary. Yeah. Okay. Yeah. Okay. Okay, that's fine. I'm not a native English speaker. That's totally fine. Happy to learn. Yeah, the editor state, which is our main kind of global state holder. Good. Okay, so let's then change this, remove this old comment. I don't think we will need that anytime soon. So what do we have here? So if I'm just thinking, so what we want is to have actually, so hovering should not only show a background of the currently hovered main menu item, but it should also already render the drop-down menu, right? Okay, so now if the current hover menu item is already designated here, that means we only need to render the actual submenu in the render top menu function. Okay, let's do that. Because this is where we use all the menus. Oh, I see an update. Compa already has another feature. Wow, you're churning out the features like hell. Perfect. Congratulations. And you have now already history command. Wow, pretty cool. Cool. So you're storing all the commands like in a sort of an array or in a vector? How are you doing that? Because, or in a stack or something like that, probably. Very nice. You just remember them, I guess, and it's cool. And then when the user types history, you can just show the contents. Good stuff. Good stuff. Cool. That's right. Absolutely good strategy. Make the things work that you feel you understand fully how they work and that you feel are simple to you, that come easy to you. I think that's a very good strategy. It doesn't make sense to overload yourself with stuff that you barely understand, and then it's very hard to debug. It doesn't work and you don't really understand what you actually want to do. That's a very good strategy for any kind of, maybe for any kind of challenge in life, but especially for developing. I think it's a very good. Good way to do it. Okay, so when we now render the top menu, that means now when we discover that someone is hovering over our menu item, we're not only rendering the nice little blue background, render a blue background on hover, and now that's new. Also, in addition, render a top-down menu. Render a top-down, a drop-down menu, not a top-down. Render a drop-down menu. For now, in the first baby step, we will just do a rectangle now, which will hopefully be located in the correct position. It will have the same gray as the main menu bar, and we will just now render it like 100 pixels of height or something like that, just to have something here. So this is again this super small step policy or strategy. I really find it very helpful in development not to swim too far from the island, so to say. It's really much better if you're always like on safe ground, and you feel like every step it totally must work, because sometimes you have a bug anyway. But if you do small steps, the actual possibility of where the bugs might be introduced is just much smaller. And yeah, these options for bugs, they grow exponentially with every line of code that you write. So that being said, we can actually kind of reuse this code more or less. So this is now like the actual hover background of the main menu item. And now what we have is the quote-unquote drop-down menu for now. It is just an imposter for now. It is just a placeholder. But we need to start anywhere, somewhere. We could even leave it in blue. I mean, why not? The color is not really important. What is important is now that we have the correct scale. Because we don't want to have it 32 wide or high. We want to have it, let's say we want to have it 100. It should still be divisible by 6, I guess. 128, whatever, 136, 100, whatever. Let's just do this. It doesn't really matter. The item width is actually a good idea, so that it's still as wide as the item. Makes sense. But more than 16 longer. We make it really quite a bit wider. Let's go with 48 just to see how that looks like. The world matrix for that is actually probably, yeah, we just reuse the one that we use for the hover marker, because we want to have it flush on the left side and you want to have it wide on the right side. So the left, the X stays the same. The world matrix really we can just reuse. I think it's even better that I just don't touch it at all. We just completely reuse it. Then we have, yeah, no, but I cannot reuse it. But I can just, yeah. Yeah. So this is the translation part of the world matrix, but I'll just keep it for now. Yeah, let's see if that even works, and then we can make it a little bit nicer. But we can already write ourselves a to-do task. Yeah, so Compa says, I feel that Linux is generally better for programmers. Yeah, probably it is. Yeah, I mean, it is in the sense that kind of like Linux feels like every like a lot of integral parts of Linux itself feel like they are kind of like contributing to like one big development environment, so to say. It feels a little bit like that. So yeah, I mean, I'm a big Linux fan. It's really kind of just So the goal, the end goal of all of this is actually also to bring out the game, to also release it on somewhere like Steam. And there I just decided for the first like outing for such a game, I think Windows is just the biggest platform still. Although I'm aware that Linux is very much catching up in terms of being a very good gaming platform, and now there's SteamOS, which is essentially Linux, of course. So yeah, but as I said, I mean, the architecture, the idea of this engine is also to be cross-platform. But I also found during the first like steps of this engine now that I think it's now still better to kind of finish it off in Windows, and yeah, then visit probably the and actually implement the specifics then for example for Linux. Then after that, I hope and I believe that the architecture is already prepared to do that. Yeah, but I would really also say that I think that working and programming under Windows, I somehow feel it's getting probably more criticism than it maybe deserves. I mean, I think it's a bit crappy, of course, and it's not very nice in terms of a lot of API functionality, and there's weird stuff, and you also kind of need at least some edition of Visual Studio, even if it's only the command line only edition to get the compiler, and this is already quite big and heavy, and it's, of course, everything's closed, or much of it is closed, most of it anyway. But yeah, I would not say it's a total mess also. I mean, I think it's fine, it's doable, it's also okay. I'm kind of defending Windows a little bit for programmers, but Linux is better, I guess. Yes, I would say so. Like if it's only black or white, and if you say which one is ultimately better, yeah, I would go with Linux as well. So to do reuse actual translation matrix from the hover code, and just, yeah, for now we'll just keep it like that, and we will just render that. Yeah, maybe that could already work. Let's just see. Let's see. Let's see how that works. Okay, that did not work at all. Okay, look, it's here, but yeah. Something's happened, but it's just, yeah, it's just wrong, just totally wrong. So the first thing that we need to do is we need to put it more in front. So that means we need to push it nearer to us. And the vertical offset is wrong, because the vertical offset is now actually 32 plus, of course, the half of the width of the height. Sorry, by 2. Let's maybe give it. Let's give it drop down height, so we can at least get rid of this one stupid value here. And then we have the drop down height. Ah, come on. Drop down height. And then we can have half the drop down height. Yeah. That should be it. Drop down height divided by 2. Cool. Okay. Yep. Yep. Try it again. Try it again. No, still not showing any any signs of working. Actually, what could be the problem here? Do we need to get this a bit further even? Why would that be the case? This is the scale, yeah. I mean, we can just, let's look at it once and then the next. Yeah, maybe I got a seizure. I don't know. I don't hope so. But maybe it was just such a tough question. Windows versus Linux. It's this kind of super hard, controversial topics. So, where are we now here? It's funny. We need to fire up render doc. It doesn't help. It doesn't help. We need to fire it up. We need to fire it up now. I need to look what is actually rendered where and why. So hopefully, yeah, okay. So let's see which one of these many draw calls is it. Which one is it? Which one is it? I need the outputs. It's probably, yeah, it should be there, right? So, which one do we have? So the first thing that is rendered is the file, then we have the import, then we have this background thing, and now that should actually be the, okay, so this should be the background. This should be the drop down. Let's see. Okay, there's no draw call. Something is, okay, yeah, look, here's the mesh. Oh, okay, I think I know what's going on. Yeah, okay. Okay, that makes things, of course, quite complicated now. Because, so what's happening is that the actual, so the top menu is rendered to a frame buffer, which is only 32 pixels high. So that is perfect for rendering the actual menu items, but it is very tough to render anything below that because we're just running out of space. So this is this very, very small little thing. No, this is called render doc. So this is another program here. This is render doc, if you mean the thing that is currently on the screen. This was not made by myself. No, this is a program I use, which is free. And I don't know the name of the person who made it, but it's called render doc. I can write it. It's a free program and it's used by a lot of game developers and game developing companies all around the world. I think it exists since several years, where it really helps you to debug graphical stuff, essentially, right? So you can really then look into the graphics pipeline, essentially, because so what it does is you can snapshot a frame, essentially. So I loaded up my game, my editor, and I pressed F12 at a certain point when I was hovering over that menu. So I now get a snapshot of this exact frame, or like when I pressed F12, and then you see everything that's happening in that frame, and you see we are. So if I have the mouse over the output, so you can see how the frame builds. So this is the capture start, so nothing's happening, everything's cleared. Then then I'm drawing the top menu. Then you see I'm drawing the side panel in separate frame buffers. Now this is this tab bar. This is the contents of the level editor. This is the asset browser on the right. And this is the status bar in the bottom, and then everything is composed together, so to say. Yeah, and into the main frame buffer. This is, so this draw call, then yeah, so this was the bottom bar, and this is the final composition. Just wondering why it's 2 times, but maybe this is just an error of myself. But yeah, you can, the nice thing is that now you can go into the detail and you can say, okay, well, what is actually going on when I'm rendering this menu bar here, and you can also go into it, and then you can see each individual so-called draw call, and then you see how this whole frame buffer is actually kind of built up. So it's first cleared. First the color buffer is cleared, then the depth buffer is cleared, then we write our first text, and you can see also how this looks like. This is, yeah, it's not so easy to see, but this is like the rectangles for each letter. You see one of those rects, and this is the import menu, and this is now, because I know currently the game objects menu is actually hovered, this is why I first draw this blue rectangle. And this would now be, and this is essentially the drop-down menu. But now the problem is that here it's over. Yeah, here the drop-down menu ends, and I cannot render it here. So we need to do this in a different way. And the question is how to do that. And I think there is not a quick win for that actually now, because what you would need to do if I load up my editor here, because what you would actually want to do is to render it over this area here. So we need to think about how do we structure this now, because now everything is kind of quite simple, quote unquote, because yeah, this is one nice frame buffer, this is one, and this is one. Everything is separated and everything is kind of rendered within these confines. But now what you need to do is actually something is originating here in this frame buffer, but we must now kind of render like in a virtual overlay frame or something like that. I'm thinking how we do this best, to actually render these drop-down menus. And actually this idea of an overlay layer kind of makes sense. I like it when I hear it. Because that could actually work for a lot of different scenarios, because it could really work for any menu at all. So if we say we might only have one active drop down or context menu, as you might call it, doesn't really matter then, active at any one time. And even if it's more, I mean, we could just have one kind of full screen layer that is just rendering these kind of objects on the top of everything else. Yeah, we could maybe do that. But is it really a virtual layer over the whole screen, or is it just, yeah, I mean, that would make it simple maybe. Oh, thank you, Eva. Yeah, thank you. It's a good point. Thank you for letting me know. Yeah, I may contact you. Yeah, thank you for letting me know. Thank you. So yeah, let's think it through. I mean, what we need is, and especially if you want to make this a little bit more generically expandable for the future, what you actually need is just a point where to render the respective drop-down menu. Because as I said, like, you can imagine if I click on this guy here in the future, the drop-down menu would just open up. The main file of this project currently is quite huge, and it should probably not be that huge, but it's currently on purpose because I just now want to keep everything like very close together before I'm kind of more sure. But I can give you the number, of course. Here it is, 2000 lines. This is the main file, and this is already probably the most long file. I mean the longest file that I have. I think the renderer is also probably not that small. The renderer itself has 1200 lines. So this is the DirectX renderer. The renderer common has 460 lines. The Windows functions have, it's rather small, 270 lines. The mesh importer has 300 lines. So yeah, it's a few thousand lines probably, if even. It's not kind of small still, I would say. The input manager is super small. I think it's only 37 lines or 36 lines. Yeah. Yeah. I mean, I will, or I can also give you the GitHub address if you're interested, because you can also really look it up. So this is the code. So if you look it up now, the most current things are missing because I need to push today, but this is the code, so it's open source. You can also look it up for yourself if you want. Hey, good, and 2 more commands. It's a very productive day or night. Very good. Very good. Very good. So yeah, I think the idea is actually to do this with an overlay. Yeah, I mean, why not? Essentially, we could just have an overlay that is just having the size of the actual screen, because this enables us to render actually everywhere we want, and we are just rendering very close to the camera, so we are like always on top essentially. Then the only thing left is we just need to tell this code that renders all these drop-down menus, because I think it will then be just centralized. It will be kind of like a drop-down system. We'll have a drop-down menu. System, like a drop-down menu module, and then we will just render everything at once. Yeah, I think that makes sense. I'll just write that down probably in my notes. Idea for general drop-down layer. Let's write that down. So we want, let's maybe make it like that, or maybe like this. We create a essentially frame buffer. Yeah? We create a frame buffer which must be cleared to transparency. Actually, that might be some fun, but I think it should work actually. Which must be clear to transparency. This will then serve as our canvas to render any drop-down menu. Each drop-down menu will just provide its own position in screen space, so we know where to put the drop-down menu. Yeah. So I think we have an attack plan, so to say, how to tackle this. But I think as we are already, or as I'm already like 1 hour over my planned time, I think I will probably now stop with the stream today, because this is anyway it's a bigger task, and yeah, I think I will probably prepare a little bit maybe off screen so that it's a little bit nicer to watch than to actually just do it. Yeah, well, I mean, let's see. I'll probably think about it a little bit more in detail, and then I think it can be implemented rather efficiently, I guess. That's at least the idea. Let's see. Okay, are there any kind of final questions of the day? Tomorrow I think will actually be later than today. So there is no real schedule because tomorrow I'm kind of busy. But yeah, thank you. So no questions, that's fine. Anyone else? Any questions? Yeah, but tomorrow probably like around 1 hour later than today, I guess, something around that. At least that's a plan. Okay, good. So if there are no more questions, then thank you for joining in, everybody, and have a good night. At least where I am, it's night. And yeah, see you soon. See you normally tomorrow, and keep it up, keep developing, keep programming, and see you soon. Bye.